Hello everyone and welcome to this video. Okay, let us continue our discussion. We were talking about binomial theorems. In the last video we discussed about the binomial expansions. Today we want to talk about the famous binomial theorem. For before that, let us see what is like combinations. How we can work with combinations here. Let's say we have n distinct objects. Distinct objects means they are different, they are not the same. Okay, and from these n distinct objects we choose r at a time. So how many combinations we can make? How many combinations are possible for them? Like we have n objects, like we have 5 objects and we want to take 2 out of them. So how many combinations are possible? We can do that with the formula, which is n factorial over r factorial into n minus r factorial. We can use this formula to make the combinations. Okay, this formula is very important because eventually it will lead us to the binomial coefficients, which is very important to understand the binomial theorem. What is the notations used for this are NCR, also books refer as NR. Example, how to solve this? 5 2. N is what? N is 5 and R is what? 2. So we have here 5 factorial over 2 factorial into 3 factorial. We have done a video on factorial. You can check that, which is the first part of this chapter. So we can write it as 5 into 4 into 3 factorial over 2 factorial into 3 factorial. It cancels and you will get what? 10. You can directly solve it on a calculator also. Like this you can solve on a calculator. If you have a scientific calculator, I like, as a student you should have 991 ES plus, it's a very good one. 991 EX, it's also good, and FX CG50. This is the graphic one. These three models of KCO are very nice. If you want to buy graphic one, I think this is the best one, which I have used, FXCG50, or these two ones are good. So directly on calculator you have option, you can write 5C2, it will surely solve you and give you the answer of 10. Okay, now our target is, what about how to solve this one? We have a plus bn. What's the meaning of a plus bn? It's basically like n time combinations of what? A plus b, right? We have a plus b, how many times? N times. How to solve this one? If you open it, we have this a plus bn. Remember we had it like a power n, b power 0. Then it will be what? A n minus 1 b. Then the next term will be a n minus 2 b square, so on up to what? Last term will be bn. The point is how to find the coefficients of this, how to get the coefficients. What is the coefficient here, what's the coefficient here, what's the coefficient here, and so on. Remember, to find the coefficients we use a triangle which is called Pascal triangle. We had what? How we started? We had it here 1 1 1 plus 1 became 2. Here it is 1. Here it is what? 1. 2 plus 1 become 3. We have 3. Here it is 1. Here it is 1. And continuingly we had it 3 plus 1 4, 3 plus 3 6, 3 plus 1 4, 1 1, and so on. But we cannot continue it to n times. Like if I want to find like 20 or 30, what should I do? I should continue adding it. It becomes difficult. So we need something more precise. Okay, for 4 5 6 it's okay, but what if I want to find a plus b power 15? So I should do first 15 times going down. So I want to use it to my advantage to get something better. Can I write this one as, if I see, it can be written as this: 1 0 1 1. For the second row, can be written as 2 0 2 1 2 2. For the third row, 3 0 3 1 3 2 3 3. For the fourth row, 4 0 4 1 4 2 4 3 4 4. Like if you solve this on a calculator, eventually you are getting the same coefficients here. Like 1 0 is 1, 1 1 is also 1, 4 0 is 1. Like you solve it, you can check it on calculator. With this you are getting the same answers of a Pascal triangle. So we can continue. For example, I want to write it now for nth row. It will be what I have here, starting from n 0, then what, n 1, so on, so on, so on, so on. I'm choosing, like for example, n r. R can be nn. Last one should be nn. So it can be what? If I want to make r combinations now, it depends, right? So this can be used. This terminology can be used. This can be used. If I choose r, it can be like what? nr. That's it. Sure, sir. Yeah. Hello everyone and welcome to this video. Let us continue our discussion. In the last video we discussed about binomial expansion. In this video we want to talk about binomial expansion. But to understand binomial expansion, first we want to understand something. Let's suppose I have n distinct objects. Distinct means they are different from each other. Distinct objects or values. Okay, and I choose at a time r from them. Like I have n in total and I select r. Like for example, I have 5 values and I choose 2. So how many combinations I can make? How many possible combinations I can make from this one? There is a formula in mathematics for this. Is what it is: n factorial over r factorial into n minus r factorial. This formula will help us me to find the number of combinations I want. Let's say I have 5. First, what are the notations? How we can write these combinations? Very famous notations are like 5C2, or generally I should talk journal first, NCR. This is a very famous notation, and also NR. This is also a very famous notation. These notations are used to represent combinations. Like I have a constant of 5 2. I want to find how many combinations are possible in this case. So what is n? 5 factorial over 2 factorial into 3 factorial. You can solve it. It will be 10. For the solution, it's better to, if you don't know about factorials, you should go and revise the video 1, and directly you can find it on calculator. You just write 5C2, it will give you answer 10. For mathematics, I prefer these 3 calculators from KCO 991 EX, 991 ES plus, or if you want graphic calculator you can use FXCG50. These 3 models of KCO are good in calculators. Now keep this thing in mind about the combinations, how we can find it. Our question is that how we can solve for a plus b n. Like if we have n combinations of a plus b, like they are multiplying, n combinations are there, how we can solve it, how we can expand it, right? If I do the expansion, it is good, like a plus b n. It's what it starts from a n, right? b0, decrease 1 power of a and increase 1 power of b, so it will be what? A n minus 1 into b, right, plus a n minus 2 into b2, so on, so on, so on, and the last term will be what? Bn. But the problem is how we get the coefficients. What will be the coefficients? How we can solve for the coefficients? Okay, let's try Pascal triangle, which we learned before. It's like 1 1, it's 2 it's 1, it's 1, 2 plus 1 is 3, 2 plus 1 is 3, 1 here, 1 here, 3 plus 1 becomes 4, 3 plus 3 is 6, 3 plus 1 is again 4, 1 here and 1 here. Problem is how much I can continue. It's like a power 4. If I want to find, for example, 20 power 20 or 12 or 10, so I have to make lot of combinations. So we need to change it to something that becomes more easy. If you check, if you do the investigation, this can be written as in the form of combination like 1 0 1 1. The second row, this will give you the same answer. It's like 2 0 2 1 2 2. Third row will be like 3 0 3 1 3 2 and 3 3. Fourth row will be like 4 0 4 1 4 2 4 3 4 4. So eventually this is like combinations. Okay, these are like combinations. Let's suppose I select the rth row. I have I have rth row, like I want to write for nr. So what will be the coefficients in this case? It will be starting from n1, n2 and so on up to where it will go. It will go to nr, right? And r can be what? R can be uh, r belongs from natural number, and eventually what can be the value? It can be 0 1 2 depending on n, right? If I want to write in generally, I can, if I want to use for example I say r is 3, r is 3, n is 5. So in this way we can use this to get that respective term. Eventually this is all combinations, like how many combinations are possible, right? Now let us go to the theorem. We have a plus bn. How we can write it? We have an. So now we can see from here what will be the next term. Next term should be what? The coefficient of next term will be what? n1. So we can write here n1 a n minus 1 into b. What should be the next one? n2 a n minus 2 b2. Going on, it will continue. Let's take a general term. Let's say if we have nr. So here should be what? Here if it is 1, see if it is 1 here it's also n minus 1, and here b power is also 1. If it is 2, n minus 2 b power is also 2. If it's r here, it will be what? A n minus r into what? B power r. Continuing, what will be the last term? Last term will be bn. This theorem is called what? This is the binomial theorem. This is can also be written in summation form. How can we write it in summation form? Summation is like this form: r starting from 0 going to n, right? Here we have what? nr a n minus r into br. This is the binomial theorem. In summation form this can be used. Now what is the advantage of this? What is the advantage? See this, let's suppose we have a question. We have like 2x plus 1 over x power 12. We want to solve this one. If you start solving with Pascal triangle, even it will take a long time, because not too much long time, but you have to write Pascal triangle up to 12 rows, and it's going to take some time and careful selection of values. Now if you use the binomial theorem, it becomes easy, right? Let's say the question says that this is the expression, find the first 3 and last 2 terms of this expression. We want to solve it. Instead of doing all that work, we can use simply the expansion to our advantage. Here we have, sorry, n value is what, 12. So let's start and apply the summation form. What will be the first one? 12, r value is 0, starting from 0, a n minus r. So 12 minus 0 will be what? A 12, plus what will be the next one? R now is 1 because summation is from 0 to n. It means like every time adding 1 to r. So 0, 1, 2, 3 up to n. So it will be what? 12, 1, a, 11 into b. He said first three terms, right? So what will be the next term? It will be plus 12, 2, 8 and b square up to so on, so on, so on. And last two terms will be what? 12, 11, a, b, 11 plus 12, 12, a, b, 12. What I did, I just simplified the values. I just put the values here because 12 and r is 12, so it will be 12 minus 12 is 0 and b 12. Right? We just used this, using this binomial theorem, we just can write the expression. Now what we have here, this is the value of what? This is the value of a, this is the value of b. You can directly replace it also in this step. I just used a and b to clarify the summation form. So we have what? 12 power 0. Here it will be what? 2x power 12 plus 12 power 1, 2x power 11 into b. B is what? 1 over x plus 12 power 2, 2x power 10 into 1 over x square, so on, because we want to find the first three and the last terms. 12 power 11, 2x into 1 over x power 11 plus 12 power 12 into 1 over x power 12. See, we just used the binomial theorem and we substituted the values and we got to this point. Now this is your first term, this is your second term, this is your third term, this is the second last term, and this is the last term. You can solve it easier on calculator. You can just use 1230, it will give you the answer, and that's it. Further it's just simplification. I think that can be done. There is something more which is called general term. If you want to find a particular term, which formula you can use? You can use this one. This is called T r plus 1 is equals to what? nr a n minus r into br. This will help you to find the any specific term. Let's say they give you a question. Example, we have a question. It says 3x minus 4 over x square power 14. This is the question, and he asks you to find seventh term. We want to find here what? Seventh term. So see, how can this term become 7? What value of r you should keep so it becomes 7? So r plus 1, it should be what? 7. So r should be what? 6. If you will put r value 6 here in this expression, you will get what? It will become the 7th term. So use r equals to 6. So it will be what? T r plus 1, it's 7, equals to what? What is the value of n here? 14. How many we have to select? What was the value of r? 6. So 14 power 6 into what? A. 14 minus 6 is how much? 8. I will directly put it. Now we have done one example, so we can do that now. Like here, what's the value of a? A is what? 3x. So 3x power 14 minus 6 is 8 into what? into minus 4 over x square power what? Power 6. You can see this is 3x minus 4 over x square. You can take it like 3x plus minus 4 over x square. Better to choose like this so that it becomes easy. A plus b format. Okay, this is the term. Further you can simplify it, and even if you don't simplify it, it can be considered correct, but to simplify it you can just use to calculate like 14(6). Like if we want to do the simplification, let us try. Let me check what is 14 C6. It is 3003. Yeah, 3003, and 3 power 8, 6561, 6561 x power 8, going to be a big term, so better to write it like this, into minus 4 power 6 is how much? 4096 divided by x16. Now these constants can be multiplied and x can be solved, so this will be your answer. Let's solve one more question. There can be a question like this. It says that you have x plus 2 power 8. X plus 2 power 8. He can ask you to write the general term in this case. Okay, and what is the coefficient of any term? Let's say x5. We want to solve this question now. Like we have an expression x plus 2 power 8 and we want to find the general term. The general term formula, is it with us? We just studied it was what? T r plus 1 equals to what? Just let me recall the formula. Yes, n r a n, come on, pen issue, sorry, a n minus r into br. Right? Now if you want to write the general notation for this, just substitute the values. What is we have here? 8 r a 8 minus r into br. When it says journal, you have to write it in a way that it can be for any value. Like this is the general term. Now if we ask you to find for any term, you can do that. Like here we asking you to find the coefficient of x5. You have to make sure that the coefficient of x is how much? 5. So here x is here. So what should, when you have x here, its coefficient should be 5. So it means that 8 minus r should be equal to what? It should be equal to 5. So what will be the value of r? R will be what? 8 minus 5 equals to 3. Right? So r will be what? R will be 3. Put r equals to 3 here. What will be the answer when you will solve it? 8 3 into what is your a? A was x, right? A is x, so replace here x. 8 minus 3 is 5 into b power r. B was, our b value is 2, so we keep here 2 power 3 because our r is 3. So when you solve this one, 8c3 is how much? 8c3, it is 56. 56 x5 into 2 power 3 is 8, so the coefficient will be 448. So coefficient of x5 term is how much? 448. That will be all I wanted to discuss in this chapter. So almost all the questions will be like this. They will give you a question, they will ask you to find the first term, second term, or the third term, or the last term of the question. All the questions are like this. All they can ask you the general term, find the general term of the question, or they can ask you to find a specific term of a question. Let's do one more practice question and then we will end the session. We have here, like for example, 2x plus 1 over x power 12. If you fully want to open it, I think this one we did already. I had it in my notes. This is done. Okay, that will be all. We'll end up here. Okay guys, thank you so much. I hope you learned something. Take care. Allah Hafiz.